So today we will discuss about chapter 7. I assume chapter 1 to 6 is done, but if you think you still have to add more content or revise code proofreading, please do. And also another agenda today is to close our midterm exam. So if you have any question on submission to Fadin before we calibrate the score, just ask question in this class. Yeah. Okay. So looking on the progress on the book, I think we can maybe we can finish the book on part 3 in this semester. I'm not sure if we can complete the whole, but we still have the next semester and the next student in the next semester. So we will focus more on the half of the book up to chapter 12. Okay. So we are at chapter 7. So in chapter 7, we deal with many data parsing. As you know, in bioinformatics, we have many type of data. So you can have BAM, BCF, BAD, BGCF, RAM, FASTA, FASTQ, GFF, and everything up to variant call file format, VCF 4.3, not including the next version 4.4. Okay, so Noodles is a good crates in RAS ecosystem where you can deal with many type of specification of the bioinformatic data. So it's also specification compliance, means that you can check, you can use this library to check the compliance. Of course, you can also read or write the file using Nodal. This is the crates page of Nodal, and this is the library. So this is the supported modules. BAM, BCF, BAD, BGZF, Core, CRAM, etc. And this chapter gives some explanation of the library, especially on advanced genomic data parsing. So this chapter starts by explaining that many high throughput systems need a capability to fast reading the files and also writing the files. So RAS is a one good option for large-scale genomic to make sure that we can optimize the performance. Let's say, for example, you are building machine that compute some bioinformatic analysis. With RAS, we expect to be able to make it faster. Okay, so there is some latex problem here. So later, if you work on the proofreading, if you find the latex like that, please fix. Usually, GPT or AI that wrote this write the latex 2 times or sometimes 3 times. So you just need to give dollar, dollar, dollar. Okay, and it will convert to latex. Okay. So in large-scale genomic tasks, usually we need to read some specific interval or location in alignment on or variant files. So we need to read it fast. And how to read that, we need data structure. Some data structure are tree data structure like red black tree or AVL tree. Okay, usually you learn about this tree if you take computer science class, but now you can get information about this data structure in GPT or any AI like Cloudie or DeepSeek. It's very common data structure. So once we put the data inside the right structure, we can find the best algorithm that's running with the best speed or performance. Okay, so naive approach usually require ON time, where N is the total number of record. But if we can make it log N, or we can make it N log N, or log N plus K, maybe it can compute faster. Okay, as we are dealing with very huge data set size, so speed is really important criteria on how good our library for reading and writing the bioinformatics files. Okay. We can also implement in high performance computing setting. This is thank you for Nextflow, because Nextflow can be deployed in HPC cluster or in single node computer like in your laptop, or in Kubernetes cluster of Dockers. So it's very flexible in terms of deployment. Okay. Uh, other than three, some people also start to use graph. You know, graph is also good data structure if you understand, really understand the tasks that you want to compute, like searching inside the sequence or reading the sequence on specific long sequence. So graph is one option that can bring the more advantage compared to tree. Yeah. Uh, but for segment reading, maybe tree is better. Okay. But for other tasks, maybe graph is better. So think of tree and graph when you read the file, and then reading to graph or tree and writing to from graph and tree to files. You have to really think on performance. Okay. So Rust Noodle is one of the modular suite for reading and writing and standard compliance of the genomic data. So, and then this is just explanation of why Rust for this kind of task. You can extend, this material. Wow, this big thunder. You can extend this material, including the sample code. So sometimes the code is not really comprehensive, as it's written by GPT, but you can use Clouder and say, let's say, revise the code to be more advanced and robust for production level quality. Okay, and then you can pass. Make sure that your prompt is good. Yeah. So the Clouder or Sonnet 3.7 can help you to make the code even better. Okay. To make it more production level code. Yeah. See, it extends the code from how many line of code becoming more advanced. Yeah. And in the book also, you have to make sure that people know what kind of version of crates that are using, because sometimes it will not compile if the type of crates is mismatched. Yeah, like for example, NDRI require this version, but your code not have that version. Okay. So here you can see the code becoming more robust and advanced for production level, and then you can pass here. Okay. So I wish you can do that for this chapter. Make sure that the sample that is given is production level, so people can get benefit from the book by just taking the code. If they like to write in Python, they can convert to Python. So let's say I say convert the code from Python to from Rust to related Python code and framework. Okay. So code translation, machine is better than us. Code construction, machine is better than us. But we still have to instruct the machine to do. because the AI will not do without our clear instruction. Okay. The reason why we put on Rust because so many book in bioinformatics written in Python, but in reality, when we deal with bioinformatics, we deal with performance optimization. We want to run the code faster on and computational cheaper. So Rust is system language that is very promising to make sure that you can optimize the process. And if you use Nextflow, you can implement some process using Rust or using C++, just in case in bioinformatics they still have C++ library that is better than others, yeah, like Booty or other library. So with the with Rust, you can have flexibility of using the hardware at maximum level, utilizing the multi-core concurrency and also GPU. Rust is the best choice of language. Okay. So, and then this is example of Nextflow pipeline generated for specific. I think you need to find some VCF file as an input, and it has a coverage analysis variant extraction. So also this kind of Nextflow code can be generated by uh, AI like Cloud, as long as you know what is your process design, right? So when I make this, I describe the process and ask the AI to generate this. Uh, okay, but you need to test section by section to make sure that our book, there is no bugs in the code. Okay, so what this file tell us? So it sets the parameters for BAM list, VCF file, and region list that it need to read. And it contains three process: coverage analysis, variant extraction, merge output. And the workflow defined by creating a channel. Remember, channel is a temporary memory for communicating between processes. Okay, process is an individual task that you can implement with any language. Okay, let's say your program Rust nodal coverage written in Rust, but variant extraction later on you find I want to use let's say C++ or Python. Other code you can use other language. Okay, as long as it can be called by the Nextflow, it's good. Okay, so that's the beauty of Nextflow. It's kind of very lightweight middleware, but very powerful for creating robust solution for bioinformatics. Okay, so section 7.2 is about high throughput sequencing or STS. Yeah. So we are dealing with data that may be in size of terabyte scale. Okay. Maybe you never deal with terabyte scale. Maybe your laptop only gigabyte scale. But terabyte scale means if I want to copy the file to your laptop, it will take hours to just copy and reading the file. But how we store terabyte data in memory? You don't have terabyte memory in your computer. Okay. So we need to be able to find, explore principle, patterns, and algorithm that's specific for this kind of purpose. So some people do in many type of parallelism, but parallelism is also really depend to what type of data structure that you need. And type of data structure depend on what kind of task you want to do with the data. Yeah. So in the previous section, we're talking about graph and tree, but is there any specific task with specific data structure for high throughput sequencing, genomic? So there is another data structure called suffix arrays and Bureau-Wheeler transform. Yeah, is And it has many implementation. One of the famous implementation we call BOTI2. Yeah. And this is C++ library for, wait, BOTI. Okay, what is this BOTI2? So it's a fast and sensitive gap read aligner. Yeah, after you read, you want to align. You see, this code is written in C++, okay, not in Rust. Yeah. Assuming you want to make something like this in Rust, this is also the good thing in current AI, right? Let's say if I have this and let me open new chat. So I will say to Cloud, analyze the structure of both the two projects in C++ and make strategy to port it to pure Rust and Bash crates. Yeah. So the good thing in Cloud now is it can goes to GitHub. So it have like a MCP protocol go to read the GitHub file and analyze and then give you the analysis if in case you want to port this project from C++. Okay. So the core component is alignment engine, index structure, read handling, trading performance utility. So Rust, of course, have a better data structure, a safer language. Yeah. So of course, it can be ported to Rust as long as you can choose what library you want to use for any specific task. Okay. So it recommends you Rust biotypes, Rust STS lib. This is one of the famous high throughput sequencing format handling. Yeah. And performance, we can use data parallelism, cross-beam, memory mapping, yeah. And then it can give you the sample code. If you have a paid version of Cloud, you can continue the process to port Booty2 from C++ to Rust, yeah. But some people say, why we have to port it? Just use it because we have the flexibility of our Nextflow, right? So with Nextflow, you can use side by side one executable from Rust that you compile from code, one executable from Booty that already have that you get from here, right? That you can install Booty in your machine with Conda install Booty, right? And then just use it, just calling it. And to call Booty, you also just need to call a program like this. So it's very easy to be embedded as a process in Nextflow. Okay. So Booty is one of the commonly used in C++ ecosystem. And of course, Python also have binding for that kind of library. But having Rust as our main language in the book, we need to show that Rust is very friendly for porting from C++ to Rust. And this open many opportunity for companies who want to, let's say, innovate, right? So imagine how many code in C++ that you can port to Rust. Okay. Okay, let's see this code. This is high performance. No, yeah, sometimes if the context is not really matched, yeah, uh, you can revise the book, yeah, as long as the example is delivered, yeah. And if you think the code is not robust enough, you can use Cloud to make it robust enough, like what I showed you before. Okay, I want this chapter done by this next week. So next Saturday we can start in chapter 8. Okay. So Next, at section 7.3, it covers about optimizing performance and memory usage. Okay. This is where system language is more performed compared to any interpret language like Python. So if we want to optimizing performance, the key things that we have to take a look is the data structure and algorithm that's running on those data structures. So without understanding the data structure, it's very hard to optimize performance. Okay. So the tools to optimize performance is usually we call it big O notation, right? You have to know what current data structure and what current algorithm running on that data structure and what is the big O complexity of the data structure. And after that, you can search in internet what kind of algorithm that much better and much faster for that specific task compared to the existing one. Okay. And the key idea in performance optimization other than algorithm data structure is cache. Yeah. Some algorithm putting everything in memory and read write from directly from memory, but they forget that the CPU has hierarchy of cache. So if you work on specific CPU, let's say you work in CPU of mobile device or server side or desktop side, once you know the architecture of the memory, usually hierarchic is structure, you can utilize it. Yeah, so you can reorganize the cache, the strategy for memory cache to make sure that your bioinformatic algorithm is running faster on specific machine. Okay, for example, block-based reading in compressed file format keeps the record aligned together, right? So by manipulating the structure of current memory or hierarchic or deeper level memory, you can make it faster. Yeah. So companies who are working with hardware level usually utilizing this strategy to make sure that their software is better than others. Other than that is memory mapping, is advanced technique, especially well with high performance computing. So yeah, but it's quite hard to try the high performance computing because in University of Indonesia, we don't have yet SPC cluster. But hopefully if we have some funding in the future, we can implement this on the cloud to utilize high performance computing. But for now, just focus on data structure algorithm, parallelization, and concurrency, and if possible, memory cache. Okay. Okay, this code is also not robust, not production ready. I believe you should make it more robust, make it more example like this. This code we can extend using Clouded. Okay. Okay, so next is advanced processing for complex genomic scenario. So many scenario is very simple, like reading specific area in the sequence, combining, comparing, look on similarity. But other tasks can really complex. Yeah. So and to execute that complex scenario, we also need specific data structure. Imagine a workflow of processes from one process to another process. We can implement the cyclic directed acyclic graph, yeah, like in Nextflow. Nextflow is actually DAG middleware. So you can imagine the bioinformatic flow like the sequence of process in directed acyclic graph, and each process communicate each other using channel. So you can implement the process in Rust and channel connecting each process. Okay. So with Nextflow, you can implement more complex genomic scenario that may be hard to implement in Python if you target higher performance. Okay. So For example, they give you example here like structural variants or SV. So large insertion, deletion, inversion, translocation, okay, for this task. And it used graph-based assembly and where local holotype partially deconstruction. So in this case, maybe you need, this is where you need Nextflow heavily because it's very hard to maintain it in one monolithic code, but you have to make sure that each process running well, each channel keep the memory well. Okay, this is where Rust can and Nextflow can really show their value. Okay. Okay. Any code in this chapter you can extend to make it more robust and more advanced. Okay. Just use the clouded. So I let you to work on that. Yeah. Okay. So last chapter, last section is how to utilize Noodles, Rust Noodle into Nextflow pipeline. So because Noodle is just like other crates, yeah, you can implement Noodles in one process, communicate uh, uh, in other process. Okay, you can implement data structure with when you read the data, you can utilize Nodal. So this section is just like integration of all the topic that we discussed in 7.1 to 7.7 as a summary. So make sure that in this section, the sample code is more robust compared to 1. Or 7.1 section to 7.4 section. Okay, that's it for chapter 7. I hope you can proofread QA, work as a team. One guy like the code better, one like the text or explanation. Other people can also help by running this sample prompt for further learning. Okay, and testing the problem solving, whether the problem solving is relevant enough to the chapter, and also whether the AI can answer this problem solving problem. Yeah, maybe you can test to Cloud or other AI like Gemini 2. Can it read that? Let me check Gemini. People say that Gemini 2.5 is much better. Let's see. Okay. So please study in collaborative way. Okay. So people who love the code, working on the code. Yeah. I will give my note here and make the code robust and advanced. Simpler. Some people can also try to run it on Gemini. Look which answer is better. Okay. So we have to make sure that is proofread and the code is well tested. And then after that, we can flag this chapter is done. Okay, that's all from me. Any feedback, any comments before we go to second agenda about you midterm semester? Is clear enough?
Good, sir.
Okay, good. Just in case that we need to release this book 2 version, so we will cut off by end of this semester at section 3. So next semester students will work in this. Okay, but this year we will deliver this book. Okay, this book will be delivered as an open source book, then will be used by Mathematics Department Universitas Indonesia and will be improved by all students who take the course. Okay, so that's it for me. Fadin, any updates on OTS Anyone who's still missing the submission or everybody completed?
Okay, let me share my screen first. Okay, so thank you, Mr. Risman. So tonight is the deadline for the midterm assignment. So I already checked on the curve note and also the tracking table on this QC assignment, and I see that some of you already done for each assigned task, and some of you maybe still trying to solve. And please reach out to me if there is some errors or anything that you want to ask. And I already see that Majeri and Trianto working on the curve note is participant uh, very active, and I hope Christian can also finish the task. And Zach already reached out to me to ask some question that he's trying to figure out for chapter 2, and the rest also he's trying to solve. I think that's the update, Mr. Risman.
Okay, so the deadline is end of today, right?
Yes, 2 weeks. Then tonight is the
Okay, 2 weeks. Okay, looks like Trianto and Majere is leading the board, right? The leaderboard. So what about Zach, Christian? You still need time?
Actually, I still work on it, sir, and I have difficulties of my device because beberapa hari ini device saya sempat rusak dan ini
Hmm.
masih pakai device lain sih. Jadi saya
So
perlu pulihin data juga, ya. Harusnya malam ini bisa selesai karena saya kerjanya di lokal, belum saya masukin ke Excel.
Fadil, you need to ask Prof. Al-Hadi, which is can we extend to Monday or we need to calculate before Monday?
okay. Let me ask Profile Hadi.
Yeah. So we will score the result from this table. And yeah, we want to make a book that everybody proud of, as this is the first in the world, I think, people writing code for bioinformatics using Nextflow and Rust. Okay. Nextflow is very active community. So once you release the book, you will be the author over there. So be excited and inspired because that will bring you more energy to work on it. And also, I hope the book will help you to do your research. So there's a lot of improvement now in genomic plus, let's say, protein folding in AI. So if you can combine genomic analysis with protein transcriptomics, there's a lot of beautiful area of research over there that very well aligned with Calbe Digital Lab. So yeah, I hope it's also help you on your master thesis. Okay, like combining AI with genomics, that is one of the plan in section part part 5 of the book. Okay, uh, but I think in this semester we can only finish part 3. We don't need to rushing out because we want quality book. Okay, so for Christian and Zach, we can extend after Fadin confirm to Prof. Al-Hadi ya.
Oke, thank you, sir. Tapi saya usahakan bisa selesai malam ini sih.
Okay, kalau gitu, and then let Fadin know ya when you are done.
Oke, thank you, sir.
Okay, as a lecturer, I really want to give everybody a score. Yeah, but it's mean nothing if you don't have the skill, if you don't have the outcome of the learning process. So what I really want to see as a success is not the score, but you can have skills on this area. So you can work in bioinformatics, which is Indonesian bioinformatics requirement is still very high, but the supply of the talent who can work on this field is very low. Okay, so make that as your motivation. What about Zach? Do you take this course from beginning, or do you have any problems, Zach?
Sorry, can you repeat? I didn't quite catch that.
Pardon, I cannot hear you clearly.
I'm saying, can you repeat a bit? I didn't catch that.
Okay. Can you still follow the course, or do you have any difficulties?
I've had some difficulties which have delayed me. That's why I'm not done with the whole thing. I've had some difficulties, especially in around the beginning when I started trying to review the code and everything. So I
Mm,
have been getting better as I have been moving on to other easier codes, and I've been getting better at using AI to help me.
mhm,
But still, I am not as fast as my other colleagues.
mm. So in that case, what is the problem? You are not familiar with RAS, or
I was not familiar with a lot of things, but as I said, I'm getting better at it. I've seen
okay.
some improvements in myself.
The best the best way to learn is to struggle, to pain, to have the pain. All right. Uh, you don't understand the language, and then you learn the language, right? So it's just a pain. It's just a pain. It's not a stopper. Yeah. So continue moving. Yeah.
Yeah.
Yeah. And you will get better time by time. Uh, Majere also have struggle at the beginning, but I think she is getting better as well. Okay.
Okay.
So you have to compare yourself also to others. Just focus on your self improvement. Make sure that you follow the course. We are at chapter 7 now. So next week, start to contribute. Some people like to find image, take more image in internet, give explanation in the text. Some people like, let's say, the code and make it work. Some people like to test the let's say the prompt and the exercise. Yeah, contributing to the books. That is the way we learn in a new way of learning, collaborative learning, to produce something that we will learn together from that output. Yeah.
Yeah.
Okay. Okay. Majere and Trianto, any comments, any feedback before we close this course?
No, sir.
Yeah. Okay.
Nothing from this side, sir.
Okay. Good, Majere. So that's all for today. Let's continue chapter 8 next week. So thank you, everyone. See you next week.
Thank you, sir.
Thank you.
Thank you.